My name is Rasiru, and I'll be showing you how to prove a trigonometric identity using a power series.
Beforehand, I did out a Pascal's triangle using integers. Then I replaced the integers with their equivalent factorials. Then I used binomial expansion. Using the first Pascal's triangle with integers, I determined the polynomial expression. Then, using the second Pascal's triangle with factorials, I determined the pattern that we would use to simplify the proof that you're seeing me do right now. All in all, it took me around 30 total hours to learn how to do this with no prior knowledge.
No more fingers, no more toes. Dr. Miller is sure to know. Counting backwards is the way to go. There's a space waiting in Poughkeepsie. Math and physics is the place. Exploration is our expectation. Geniuses we do make, so don't wait. Make a date, we're here to wait. No more fingers, no more toes. Dr. Miller is sure to know. Counting backwards is the way to go.
Okay, so now I'm going to explain what I just did and what you just saw in the speeded up video. Alright, so here we have cosine of x and sine of y written as power series, and using binomial expansion we are going to multiply them out, and then we're going to collect the terms with like exponents and get this. Now we're going to do the same thing with sine of x and cosine of y, and again, similarly, collect the like exponents, the terms with the like exponents. Now, we're going to add up the two products, here and here, and again, we're going to collect the like exponents. And to get from this step and simplify it, of course, you can see here that I didn't go out to the fifth term because of space constraints, but you can see that to get from this form to this form, we're going to have to use binomial expansion, which is written out over here. And binomial expansion, we can see that using binomial expansion, x plus y to the third, using Pascal's triangle with integers, is equal to this form. And replacing those integers with factorials, we can see that it is equal to this form. Now, comparing this and this, we can see that it's identical except for the fact that here we must divide it by 3 factorial. And that, seeing the pattern, we can see that that is, that using patterns we can determine that that is going to continue on. And that now we can see that that is equivalent to sine of x plus y, and thus we can say that cosine of x sine of y plus cosine of y sine of x is equivalent to sine of x plus y. Now I have shown you guys that I can prove sine of x plus y is equal to cosine of x sine of y plus cosine of y sine of x using the power series approach rather than the geometric one. So now I present this to you as a challenge to do this the same exact way that I have done it, and if you are successful, to post it as a message on the Facebook page of Math and Physics Exploration. Okay. And if you would like to get more information on math or physics or how to do this particular problem, you can always visit the website for Math and Physics Exploration, which is Math Physics Explore.org.